All right, it's 8 o'clock, so we'll go ahead and get started. No, it's an early morning, but let's go ahead and get this knocked out. All right, so this week it was all about loops, was the material. All right, let's log in here. Let's have our Python file. So let's talk about loops. Loops is an easy way to execute the same piece of code over and over repeatedly. Say if you want to, let's imagine if we want to get some input from the user, maybe we want them to type in 10 numbers, right? How do we get them to type in 10 numbers? Well, we could do something like this: input, enter a number, right? And we could do that, let's just say 5 times. So I have to type it in 5 times. Here we go. So this will allow the user to enter a number 5 times, right? Let's save it. Let's run that. Python 3 file. Enter a number 1, 2, 3, 4, 5. That lets me enter in a number 5 times, right? Let's imagine we wanted to sum up the numbers. For instance, if they type in 5 numbers, we want to count the total. Maybe it's like a grocery store and we're adding up how much their groceries cost, right? Let's just call it cost. Start out to be 0. And each time they type in a new number, we'll add that to the cost, all right? Just space it out a little bit so it's more readable. And then at the end, we'll just print out what the total cost was. Okay, so cost starts out to be 0. We will enter a number 5 times, and then each time we just add that to the cost, and at the end we'll print out the cost. Okay, let's save it. Let's run it. 1, 2, 3, 4, 5, and there you go. The total cost is 15. Okay. Well, what if we wanted to do 10 times, right? So if this is 5, if we repeat that again, that's 10 times, right? Let's save it. Let's run it. 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, we'll have 0 as the last one. There you go. The total is 45. Okay. What if we have it 50 times? Do we really want to keep copying and pasting that same code over and over and over when really it's the same 2 statements repeated over and over and over, right? So instead of copying and pasting this until the end of time, we need to have a way to repeat this same code and just execute the same code over and over and over until we don't want to execute it anymore. Okay. So the way we do that is with a loop. And it kind of looks like this. Delete all these extra ones. This is a little bit of pseudocode here. So we'll have a loop, colon, and then just like with an if statement, how we tab it over to indicate the code that we want to be executed as part of the if statement, we also tab over code we want executed as part of the loop. Now the loop isn't actually a real Python command. That's a little bit of a pseudocode. It's just we're going to put something here that designates it as a loop, and then we indent over the code that we want it repeated over and over and over. Okay. So there are actually several different kind of loops that you can do. Let's look at the first one. First one is called a while loop. And it looks something like this. First, you have to have kind of a variable that's going to act as your flag. And what I mean by flag, it means as long as this variable is true, or as long as this statement is true, the loop will keep executing. Let's see what I'm talking about. So we have a variable n equals 0. All right. So as part of the loop, the keyword is while. That's what makes it a while loop. Now here we need to put in some kind of mathematical comparison. And as long as this comparison is true, the loop will keep executing. So for example, if we put while n equals 0, keep repeating this loop. Actually, let's do it like this. While n is less than 5, oops, is less than 5, we're going to keep repeating this loop. So let's think about this for a second. So initially, n is 0, right? So we're going to get into this while loop, and it's going to say, is n less than 5? So is 0 less than 5? That is true. So it'll do all the statements inside the loop, all the indented statements. After the last statement, it'll come back up to the top of the while loop. Let's see if I can zoom this in. There we go. That's probably better to see. So after the last statement in the while loop, it'll go back to the top of the while loop, and it'll check this again. It'll say while n is less than 5. So n is still 0, and 0 is less than 5. That's true. So it'll execute these statements. Then it'll go back to the while loop again. It'll check this again, and it keeps repeating that forever until this ends up being false. When this ends up being false, then it does not execute the while loop, and it just goes to the code after the while loop. Let's put a little string here. Cost is this much, right? But as it is, this will always be true. And why is that? That's because I make n equal to 0. And so 0 less than 5. 0 is always less than 5. So this will always be true. So what we need to do, we need to figure out a way for eventually this to be false so that we can stop doing the while loop. We can do that like this. N plus equals 1. So what's going to happen with that? So you think the first time here, n is 0. 0 is less than 5. So it's going to do this code. And now look, n is going to be 0 plus 1. So n is now 1. We'll come up here. 1 is less than 5. So it'll execute this. When it does this, n is now 2. 2 is less than 5. And it keeps repeating this. Eventually, this is going to make n equal to 5, right? At some point, n will be 4. We'll do n plus 1, making n 5. Now, when it comes up here and checks, it'll say n is 5. Is 5 less than 5? And that is false. So it will skip the loop, and it'll go to the code after the loop. So what you'll see this ends up doing is it will repeat this code 5 times. So that's the inputting a number 5 times. We could put 50 here. Now it's going to ask you to input a number 50 times. You can put 5 million or whatever that is. It'll run this same code 5 million times, asking you to input a number. So for brevity's sake, let's just change it to a 3, and we'll actually let's leave it at the 5 like we've been using. Each time in the loop, I'm going to print out what the value of n is. Print the value of n is equal to n. That way, each time in the loop, we can see what the value of n is. Let's save it. Let's run it. And you see right now, the value of n is 0. So enter a number, 55. Now the value of n is 1. Let's keep going. N is 2. N is 3. N is 4. And then the loop is over. So the last time in here, n was equal to the value of 4 because 4 is less than 5. So it'll do this. When we get here, n is 4. We add 1 to it. N is 5. We come back to the top of the loop. 5 less than 5, which is false. So it will skip the loop and goes directly to the code after the loop. That is what your basic while statement looks like. And it's the way to execute the same piece of code over and over and over until a certain condition is met. Now, you don't have to use less than here. You can use any of your mathematical comparisons. You can use less than or equal to. There's greater than or equal to, not equal to. I think that's the main ones that you can use. But whatever you have right here, it just needs to be some kind of mathematical comparison that can either be true or it can be false. Okay, so that's what your basic while loop looks like. And as I said, it's a way to repeat the same code over and over and over, so you don't have to copy and paste it 10 times if you wanted to get 10 inputs. And it doesn't just have to be for inputs. We could use it to do just some kind of math in here, right? So I'm going to take out the value of n. I'm going to take out the input. We could do whatever we want to in here. We can say print anything, whatever. The point is, it's just some kind of repeated code that you want repeated over and over and over. You can do input, but it doesn't have to be input inside of there. Okay, so that is your basic while statement. What you have to be careful of in here, though, is sometimes you can get caught up into what we call an infinite loop, meaning the loop never ends. And that's generally bad for any of your programs, is if you get into an infinite loop. So let's look at an example of them. So let's do this again, where we print the value of n. Value of n is equal to n. Let's go back to the example where we're getting an input from the user. Enter a number. And then we'll add it to the cost. Kind of the same thing that we had, right? Okay. So how can we get a loop that never ends in here? So as we looked a minute ago, n starts out at 0, and as long as n was less than 5, then it kept repeating. As soon as n was not less than 5, it skipped it. What if we made a mistake and we said n is greater than 5, or n, let's just use that example. Actually, no, let's keep the less than 5. And let's say we forgot this line here. Let me comment it out. Let's say we forgot to increase n. So if we do not do that, this loop will never terminate, because n stays 0 forever, right? We run it. What do I do? Oh, not input, input. Now let's run it. You enter a number. As you see here, no matter what we type in, n is staying 0 forever. So if n stays 0 forever, this loop will never end. It'll go on forever and ever and ever. Like, if we don't bother asking for the input, and if we just run this code over and over and over, you see, like, it's continually printing out n is equal to 0 forever. Infinite loops aren't really useful in programming. There are certain occasions where an infinite loop can make sense, but for the most part, and especially for this class, an infinite loop just doesn't make sense. Another way you could do an infinite loop is, let's say we do have it in there. We can put the word true there. Like I said, the loop will keep executing as long as this remains true. And Python has this key word called true, and that means it means true. When I use the word true, it means true. Okay, so every time it checks this condition here, it will always be true. And so it will always execute these statements repeatedly. So if we run this, it's just going to count up in for forever. You see there, the value of the n keeps going up over and over and over and over. All right. So that's what a infinite loop looks like. Generally, if you find yourself caught up in an infinite loop, you've probably done something wrong and you need to correct your error. It's not always a bad thing, but it's usually a bad sign. Okay. Let's look at the for loop. The for loop is just another way to do a loop using a little bit different terminology and different syntax. And it's usually used if we have a list of things, not always, but it's usually involved with a list. And what do I mean by list? So let's imagine we have, let's go back to our grocery example. Let's have a variable equal to groceries. And this is going to be all the groceries that we put in our shopping cart. All right, we have a list, and this is what a Python list looks like, but we have a list of groceries, right? And a list in Python looks like this. It's the two square brackets. This means groceries is a list. And a list is just a single variable that can represent a bunch of different values. So for groceries, I want it to be a list of what groceries we have. And for that, I'm going to use a string. And so if we want to actually have values in our list, we can do it like this. We can put milk. It's like this. Let me delete the rest of this right now. Here we'll print out groceries just so we can see what's going on. So right now, I have a list of groceries, and the only thing in the list is milk. When I print it out, it's going to print out everything in the list. Let's take a look at that. You can see here, it prints out this list with milk as the only item. Let's say we wanted to add bread. This is how we do it. When you have multiple values, you will separate them by comma. Now we have two things in our list, milk and bread. Save it and run it. You see here, when we print it out, it's the same thing. That variable has milk and bread in it. Let's add cereal. Let's add eggs. I really like breakfast. Let's add bacon. All right, that's enough things. Let's save that. And let's run that. And as you can see, that single variable groceries is the list of all of these things. And it doesn't necessarily have to be strings. Let's just make another list. It can be numbers. 1, 2, 7, 3, 9, 11, 1, or whatever. So if we print out this list, this is just a list of numbers. Oops. There we go. Save it. All right. As you can see, this A is a list of these numbers. You can see that right here, right? So you can have a list of strings. You can have a list of numbers. You can have a list that is both of them. That is strings and numbers together. Whatever we want to call them. Save that. See there, this list is strings and numbers. I would say you can do that in Python. It's not very common. Usually when you have a list, the items will be alike, meaning all of these are strings, all of these are numbers. You really won't very often see a mix of them like this, but Python does let you do it if you find a use case that you need to do this. All right, so let's delete these out. So how does this relate to a for loop? Well, as we said, this groceries it is all of these values. It's not one single value, right? It's all of those values. Well, how can we access the individual values? Well, one way we can do it is with a for loop. And it looks like this. For G in groceries, colon, do something with G. So it's a little bit like the while loop where we have, the colon, and then we tab over the code that is part of the loop. But what is this doing right here? So this is saying for G in groceries. So we already know that groceries is this list of all of these items, right? What the G does, it makes a new variable called G, and each time through the loop, G will represent one of these values. So the first time in this loop, for example, let's just print out what G is. So the first time in this loop, G is milk. The second time, G will be bread. The third time through the loop, it's cereal, and then eggs, and then bacon. It's each individual value one at a time. So here at the top, before the loop, let's print out groceries, which is the whole thing. Then we're going to do a loop that goes through groceries one at a time, and we'll just print that out, that one single item. And let's look at that. So run it. So you see here, this is groceries, which is a list of all the items. But now we have this loop that's printing out G. So G is just milk, then G is just bread, then G is cereal, G is eggs, and G is bacon. So it does one at a time. So this is how we use a for loop to go through a list of items. And how is this useful to us? Let's say, let's stick with our grocery example. Let's ask for the cost of each grocery. So let's get some input. A is equal to, let's make it a float since the cost can be in dollars and pennies. Get input, enter the cost of G. Then we'll take the cost plus equals G, and then at the end, we'll print out the cost. So what's happening here? So as I said, each time through the loop, G is equal to this individual item. The first time is milk. So we're going to say enter the cost of G. So it should say enter the cost of milk, then enter the cost of bread, enter the cost of cereal, so on and so forth. And then again, we just keep up with the total cost of everything and then print it at the end. Let's run it. Oh, got 3. Oh yeah, I don't think I can have this extra comma on there. Maybe save it and run it. What did I do wrong? Oh yeah, that only works for print. Oops. Okay, so we'll do enter the cost of, I think we can add it like that. Yeah, there we go. So we'll enter the cost of, then we'll print out G, and then we'll do a little colon to make like a prompt, right? Let's say, there we go. So we say enter the cost of milk. So that's how I've used the G. I'm able to prompt the user which specific item to enter the price for. $1.11. Cost plus equals A, what they input. See, even I make mistakes. That's why you run it and test it. So milk is $1.11. There we go. Cost of bread, $2.22. Cost of cereal, $3.33. Cost of eggs, $4.44. Cost of bacon, $5.55. And there you go. At the end, it adds it up and totals it for you. So that's how we've used a for loop as I said, to go through this entire list, but one item at a time. Okay. There's another way to do a for loop. Let's imagine we don't have a list. Let's just say we want to do a loop 10 times. Well, we saw earlier we could do this in a while loop, right? While n is less than 10. Then here we'll just print n, right? You know, that while loop doesn't loop 10 times. Oops, we forgot. Got to add one to our n, right? If we run that, of course, it loops 10 times and prints out all those numbers. That's one way to do a loop a set number of times. The other way is also with a while loop, and is with a for loop, and it looks like this. You have for I in range 10. Here we'll print out n. These two loops actually do the same exact things. Let's have the while loop first, and then we'll do this for loop. These two loops do the exact same thing. So as we saw earlier, when we used the list of grocery items, here we're kind of doing the same thing, except for this time, instead of G in groceries, we're going to have I in range. And this I just represents a variable name. The same way with G, it didn't have to be G. It doesn't have to be I. This can be whatever you want to call it for a variable name. You know, any name that works for a variable, you can use here, and that's fine. We just have to make sure that's the variable name that we put right there. I like to keep it for this kind of for loop. I like to keep it as an I, just keep it short and simple. But what does this do? This range 10. What this range 10 does, range 10 is actually equal to this list. 7, 8, 9, yeah. Range 10 is actually equal to this list of numbers. And so we saw earlier when we did for G in groceries, meaning G was each of those items each time through the loop. This works the same way. I in range 10, where range 10 is this right here. 10 consecutive numbers starting at 0. So that means each time through the loop, I is going to be equal to 0. Then next time I was 1, the next time I is 2, the next time I is 3, and so on and so forth. So to show you they're the same, so we'll leave this while loop to print that. Then we'll print now doing for loop, and we'll see that they end up being the same thing. Move this out of the way, and there you go. That's the while loop. Now doing the for loop. The for loop is the same. So this is another way to do a number of an amount of code. How many ever times? This could be 1,000,000, and that's fine. It'll repeat this 1,000,000 times. So there's two ways to do a for loop. Okay. So that's the while loop, that's the for loop, and that's really the two loops that we have in Python to repeat the same code how many ever times you want. Okay. Well, how do we actually use it? How is this useful? I think I've given some useful examples, summing up the total of your groceries and things like that. And actually, that really covers the next two sections of our Python material for the week, is counting loops and summing loops. I just showed you a summing loop when we did the groceries. Let's look at it one more time. We'll have grocery. Let's see if I can undo it that many times. Yep, there we go. There we go. That's back to our for loop with groceries. And part of the material this week was summing loop. Well, that's exactly what we've done, isn't it? We started off with cost being 0. We have a list of groceries. We're going to loop through each grocery. We're going to ask for the cost of that grocery, and then we're going to add that cost onto our sum. All right. So that's one thing we can do. So now that we have the total cost of our groceries, we can do a lot of stuff with that, right? Let's figure out what the tax is on our groceries. Let's say our tax rate is 4%. Let's calculate the tax is equal to the cost times the tax rate, right? So we'll print out cost. Make a little grocery store application here. We'll print out the cost. We'll print out the tax. Then we'll print out the total, which is cost plus tax, right? So this is something useful we can do with our for loop. Let's run it. Milk is 1, 2, 3, 4, 5. There we go. The cost is $15. The tax is 60 cents. So your total is $15.60. Right. That's because we went through and summed up the total of the cost. And then, down here, computed the tax. We could do the average cost. Print average cost. And how do we get the average cost? The average cost is just what, let's just go with the total divided by how many, actually, this is a good place to show this. So, what is the average? The average is the sum divided by how many things you had, right? So if we look at average, it's equal to the sum divided by how many I had, right? The average there. So what is the sum in this case? The sum is the cost, right? That's how I kept track of how much everything costs. And how many did I have? Well, I had 1, 2, 3, 4, 5, right? So there's 2 ways you can go about this. You can go about the smart way or the not so smart way. Let's do the not so smart way first. So I can put 5 here, right? Let's take out the tax rate stuff right now just to get it back to being simple. We'll still print out the cost, and then we'll do the average cost, okay? So for the average, I could say the cost, which is how much everything costed, divided by 5 because I had 5 items, right? Let's run that. 1, 2, 3, 4, 5. The cost is 15, and the average cost was $3, and that is the average of all those numbers. Okay. Well, let's say I decided to not get bacon. Let's take bacon off there. Okay. Now let's run it. Is this going to give me the right answer? 1, 2, 3, 4. It says the cost is 10, and the average is $2. Is that right? Well, let's see, 4, 5, 6, 7, 8, 9, 10. The cost is 10, and we have 4 items. So actually, the average should be $2.50, right? Why did I get the wrong answer here? Well, I got the wrong answer because instead of 5 items, I now have 4 items, right? So I should change that to 4. Let's save it. Let's run it. Now, if we run it, we get the right answer, right? Okay. Let's say, well, I really like bacon, so I add bacon back to it, but I also needed to get something else, soup, right? Okay. Well, now how many do I have? I have 1, 2, 3, 4, 5, 6. I have 6, so you change that back to 6, and then put it in, and it gives me the right answer. Okay, what if I order 100 items? Do I need to constantly count how many I have in there? No, let's use a Python built-in function. We talked about functions last week. It's called LEN, stands for length. And we put the list that we want to get the length of. Let's do a print on that so we can see what it actually is. Groceries. And that is actually the number of items. And how does that work? So the length of groceries tells me how many items are in this list. And so that's how average is computed. Again, you take the total divided by how many items you have. And this length of groceries tells me how many items I have. Let's run this. 2, 3, 4, 5, 6. It tells me the cost was 21. There were 6 items and the average is 3.5. Now I could chop off a lot of this and go down to just 2 items. Now I don't have to change any of this down here because I'm computing how many items we have. All right, let's run it. 1, 2. And that ends up being the right answer. So that's how we're kind of using a summing loop, adding up stuff into a sum, and then the different things we can do with it, such as printing it out or calculating the average. Hint, 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 homework assignment. Okay. 2 more things we want to look at, and then we'll wrap it up. So, and these 2 go hand in hand, so I'll cover them both simultaneously. So let's say we have a list of numbers and we want to find the biggest number, or we want to find the smallest number. Well, first let's look at the biggest number. So let's start out with a list of numbers. Numbers equals, let's just make a random list of numbers. Oops. All right, that's a random list of numbers, right? So how do we find the biggest and smallest? And the hint is we find those with a loop. So as I said before, when we have a list, you generally want to use the for loop. You can use the while loop, but generally you'll use the for loop. So let's go through each number and find out what is the biggest one. With the for loop, for num in numbers. Let's just call it like that. And so what is num going to be? The first time in the loop, num is 1. Then num is 65, num is 8, num is that, and so on and so forth, each time through the loop. So we need a way to find out what is the highest number. So how do we do that? Well, if we think about it logically, we'll look at the first number and we'll say, well, the highest is 1 because we don't compare it yet, the first one. And then we'll say, is 1 greater than 65? No. Okay, 65 is my highest. Is 65 greater than, so far 65 is the biggest. Now we're going to say, is 8 bigger than the biggest? 8 is not bigger than 65, so it's false. Okay. Now we'll say, is this bigger than the highest? The answer is yes. So now this is the biggest, right? Then we'll say, is 98 bigger than this? No. Is 1 bigger than this? No. Is 3? No. Is 88? No. So we need to keep track of what is our biggest number. What is it? Actually, we don't know what it is yet, right? So let's leave the question marks there for now. And so we need to say in pseudocode, is num greater than biggest? If it is, then the biggest is num. That's kind of the pseudocode for it. And does that make sense? We'll say, is the number we're looking at right now, is this specific number greater than the biggest one I'm keeping track of so far? If it is greater than, then the biggest is that new number. So let's change that from pseudocode into actual code. So is num greater than the biggest? Is num greater than the biggest? Easy as that. If that's the case, biggest is num. Biggest equals num. Okay. The question is, what does biggest start out to be? Let's imagine, let's do this. Let's throw in -8 or whatever. Let's say the biggest starts out to be 0. Is this going to work if biggest starts out to be 0? The answer is yes, because we'll get to the first number. Num will be 1. Is 1 bigger than 0? Yes, it is. So the biggest is now 1. And that works throughout there. How will this well, that works for now. Let's run that, and you can see, oops, if, not is, it's if, right? Oh, and then we need to actually print it so we know what it shows. At the end, we'll print out what the biggest number is. There we go. So 2435 is the biggest number. Is that right? Absolutely, that is correct, right? Okay. But will this always work if we set biggest equal to 0? What if we have this? -1, -2, -3, -4, -5. What is the biggest number in here? The biggest number is actually -1. It's a little bit counterintuitive with negative numbers, but -1 is the biggest number. Let's run it. What's going to be the answer here? Oh, it gave me that 0 was the biggest number, but that's not right because I don't have 0 in here. 0 is not in my list. So if we start biggest with 0, it may not always give us the right number. If 0 is bigger than everything in my list, it's going to give me the wrong answer. Well, what if we put minus, that's a pretty, that probably works, right? If we go with that, indeed, that does work. It tells me -1 is the biggest, which is correct. But what if our numbers were this? Now what's the biggest number? Again, it's still going to fail us and tell us that this was the biggest number, even though it's not, because it's not in our list. So we need a way to determine what this biggest should be. Let's go back and put reasonable looking numbers. There we go. So Python has this concept of none. And what is none? None means nothing. It doesn't mean 0. It does not mean, it does not mean 0. It means it has no value. So if we leave out this code, if we just print the biggest is none, what does it print to us? It is none. It is not 0. It is not a specific value. It is no value. If we look at the type, what's the type of biggest? The type is none type. None means it has no value. It is not any specific value. So what we can do here, we can use that to our advantage. We can say if the biggest is none, or num is greater than biggest, then we want to do this. And how does that differ? So the first time in the loop, biggest is none, right? It is no value. So we'll start our loop. Num will be equal to 1. And now I'm going to say if the biggest is equal to none, and in the first case, it is, right? So it's going to say, well, biggest is none, so the biggest is now equal to this first number. And the way this helps is it helps catch the very first number in your loop. Now the next time through the loop, so biggest is 1. The second time through the loop, num is equal to this 65, right? So if 1 equals none, that is false. Biggest is no longer none. Or 1 is greater, or 65 is greater than the biggest, which is 1. 65 greater than 1, that is true. So now the biggest is equal to 65. Let's save it and let's run that. And you'll see it gives us the right answer. Even if we put, no matter what values we put in here, this will always work now. Oh, yep, that gives us the biggest value. Oh, if we put in some more numbers here, that should be the biggest value now. Sure enough, that's the biggest value. And it'll work no matter what values you have in your list for the biggest. So how can we change this into the smallest value? Super duper duper easy. And how do we do that? It's just a matter of changing this comparison. Here we want to see if the number is greater than the biggest. But now let's make it less than. That'll get us the smallest number. And if that's the case, we probably don't want to call this biggest anymore. Let's just call it small, because that's more descriptive of what it is, right? As you can see here, the only thing I changed was the name of the variable and this mathematical comparison. If I run it, now it gives me the smallest value. And to show you that the name of the variable doesn't matter, let's just call it that. The name of the variable doesn't matter. That's still going to give us the smallest, and it does. And to get the biggest, all we have to do is flip it from less than to greater than. Save it and run it. And there we go. It gives us the biggest. So that is your basic loop about how to get the biggest or smallest number. And that is all of this week's material. Let's talk about the assignment just for a second. But for your assignment is to compute the average quiz grade for a group of 5 students. Well, we've actually done almost exactly that, right? We got the average cost of groceries earlier in the video, right? Seems very similar to computing the average quiz grade for a group of 5 students. And the assignment tells you to specifically use a for loop, use a list of 5 names, and so on and so forth. This is very similar to what we did for the groceries example, when we were getting the input for the cost of a grocery, and then at the end we displayed the total of groceries and we displayed the average cost of a grocery, right? Take the grocery language and change it into quiz grade language. But the basic layout of code should be fairly similar. All right, that's all I think I really need to cover about the assignment, because we've done something pretty close to the assignment already. Okay, and that will wrap up what I had to talk about for this week. So I'll go ahead and open it up to questions.
Professor Steffi, for the test case, do you want us to put like, I guess like biggest, and then what obviously we think the output would be, and then what we got? Or how do you want that done?
Yeah, for the test case, so the output of your program should be the average of the grades and the highest grade, right? So there's actually 2 outputs for your program. So when you, in your expected output column, again, you should manually compute those, But in your expected output, you should put the average and the highest. And then in your actual output, you should also put the average and the highest, whatever your program printed out. Does that answer your question?
Yes, thank you.
Okay. If you have any other questions, go ahead and let me know. If not, I'll go ahead and wrap it up. I think you're the only one on right now.
Yeah, I don't have any other questions. Thank you.
All right. Have a good morning.